Okay, welcome folks. This is Foundations in Pre-Calculus Math 10 with Mr. Johns. And today we are starting Chapter 2, which is called Trigonometry. And Section 2.1 is the tangent ratio. So we're going to use the tangent ratio to find an angle measure. And here's an explanation of the tangent ratio. And if we can understand this ratio, then the other ones that come along will be quite easy. So the first thing is to know that this is a right angle triangle, and that's what we're going to be working with throughout this whole chapter. Now the side opposite the right angle is always called the hypotenuse, and this is the longest side. The other two sides are the legs of the right angle triangle, and they can vary in name. So here we're going to talk about angle A, and it's an acute angle in a right triangle. And then tan of A, or the tangent of A, is equal to the length of the side opposite A over the length of the side adjacent to A. So if I have angle A here, the side opposite is straight across from the triangle. The side adjacent is beside. And I easily remember this by saying TOA. So the tangent of angle A is equal to the opposite over the adjacent. Opposite over adjacent. So, I know you don't quite understand it yet, but the size of this angle in degrees is a ratio related to a ratio of the opposite over the adjacent. So let's try to use it and see if it makes more sense. So now we're going to find the tangent ratio. So now we want to find the tangent ratio of angle P. So if we're talking about angle P, the side opposite of P is RQ in terms of the letters, RQ. The side adjacent to angle P is right beside it, and it's not the hypotenuse, is PR. Whoops. And so the tangent of angle P is going to be the length of the side opposite angle P over the length of the side adjacent to P. And so this is equal to RQ over PR, which in numbers is equal to 10 over 8. And I can write this as 5 over 4, which is also equal to 5 divided by 4, 1.25. So this is just a number that represents the ratio of the opposite side over the adjacent side in relative to angle P. Tan Q is this angle, and the side opposite of Q is PR. Here. The side adjacent is right beside, and it's not the hypotenuse. This is RQ. And so this is going to equal the length of side opposite angle Q over the length of side adjacent to angle Q. So we have PR over RQ. If we use the numbers, we'll get 8 over 10. This can be reduced to 4 over 5. And if I was to write this as a decimal, tan Q equals 4 divided by 5. Whoops, 4 divided by 5 is 0.8. So this angle is bigger by a little bit, looking at the two ratios. So now we're going to use the tangent ratio to find the measure of an angle, for example angle P or angle Q, in terms of degrees. Okay, so we want to find the measure of each indicated angle to the nearest degree. So we're talking about angle F, and that's this angle here. So the side opposite of angle F is across the triangle, and this is GH. The side adjacent to F is right beside, but it's not the hypotenuse, it's the one beside. And this is FG. So we want to take the length of the side opposite, angle F over the length of the side adjacent to F. And this would be GH over FG, which is 13 over 10. And to move tan across the equal sign, we'd use what's called tan inverse. So the measure of angle F is equal to tan inverse 13 over 10. Then we use our calculator. So I do 13 divided by 10 equals 1.3. Then I do shift tan, and this gives me tan inverse, which gets me to 52.43. I'll put a little dot over the equals, and this as a to the nearest degree, I'd round down to 52 degrees. Now with angle E, this is here, I'm going to take the opposite over the adjacent, not the hypotenuse. So the side opposite is CD, the side adjacent is DE. So we want to take the opposite over the adjacent, and this is CD over DE. If I just use the numbers though, this is equal to 5 over 9. To bring tan across the equal sign, I'll use tan inverse of 5 over 9. And then I'll use my calculator to do 5 divided by 9 equals this number, shift tan inverse, and I get 29.05. So the angle of E is equal to approximately 29 degrees. There we go. So lastly, we're going to use the tangent ratio to find the angle of inclination. So this is going to be some type of word problem. And basically the angle of inclination is an angle that goes up, often from the ground or somewhere else. So a ladder leans against a house. The top of the ladder is 2.4 meters above the ground. And so here we have 2.4 meters. Right? It's 2.4 meters above the ground to the top of the ladder. Its base is 0.9 meters from the wall. And you'll notice I'm using my picture and filling in the information. What angle to the nearest degree does the ladder make with the ground? And so this is this angle. Label the given triangle FGH, where label G where the ladder meets the ground, so that would be here. Label F where it meets the wall, up here, because this is the ladder. And this would be H. So we want to find the measure of angle G. So the side opposite of G is across the triangle, it's FH. And the side adjacent to angle G is beside it, but not the hypotenuse. This is GH. So this is going to equal the opposite over the adjacent. Tan G equals the opposite over adjacent. And as far as numbers go, it's 2.4 over 0.9. Opposite over adjacent. FH over GH. So angle G is equal to tan inverse of 2.4 over 0.9. And I'll use my calculator. So 2.4 divided by 0.9 equals a number. Shift tan inverse is 69.44. So the angle G is equal to the nearest degree, 69 degrees. So this is 69 degrees. There we are. For section 2.1, we'll do 1, 2, 3, and number 5. Good luck. Let me know if you need help.